Welcome, everybody. I am Jim Durkin, a systems engineer at Cisco, and we're going to be giving an overview on secure access in this session. So thanks for attending. My focus at Cisco is on multiple platforms and technologies, including security and secure access. And I support a very large managed service provider, which I've been doing for a number of years now, and they have just recently launched secure access. So before we get started, I want to remind you there is a space created for this session, so please post your questions, your comments, either during the session now or afterwards, and we have monitors in the room to answer all your questions. So here's how I'm going to break up the session. I'm going to give an overview of what secure access is, talk about the different use cases that you can use it for, and then get into some of the details about the different network connections that we support in secure access, and then we'll wrap things up. So Cisco Secure Access, that is Cisco's SSE platform. For those that are familiar with Umbrella, it's an evolution of Umbrella. So some of the same security capabilities in Umbrella will be in or is in Secure Access. And it is a cloud-delivered platform, cloud native, meaning all of the inspection is happening in the cloud. So we support a number of core capabilities in Secure Access. Secure Web Gateway is one of those. That's about web content filtering. So that's where we prevent users going to certain categories of websites. We also provide protection to ensure users don't land on malicious websites. And then we also analyze the traffic from the users to ensure malware is not downloaded. Zero Trust Access. That is a modern approach to provide users to private applications. So think about a user that needs access to a private application in your company. This would be a good way to do that. And later, I'll talk about some of the differences between Zero Trust Access and the classic remote access VPN approach. We support a stateful firewall in Secure Access, as well as what we call Cloud Access Security Broker, or CASB. CASB is monitoring users' traffic to SaaS applications. So users going to cloud applications, whether or not IT has approved that or not, you can use CASB to provide you that visibility, try to figure out who is going to which cloud applications, and if you want to, limit or prevent users from using certain cloud applications. We do provide a lot more capabilities than what you see on the left. We support what we call VPN as a service. Essentially, that is a VPN head-end that we have added to Secure Access so that remote users can VPN into the platform. We support digital experience monitoring. That's all about monitoring the health of the user's traffic going through Secure Access, ensuring that everything is working. We also are able to look at the health of the end device. So it's a great tool that we have using this for admins when there are problems or issues that need to be isolated. DNS security, this is the same set of capabilities that we have in Umbrella. Basically, we have brought that over into Secure Access. Remote browser isolation, this is isolating the user's browser activity from their device and instead host that browsing activity right in Secure Access. And then we also can prevent and detect malware from being downloaded. And when needed, we can spin up a sandbox to analyze files that have never been seen before by Secure Access. analyze it, execute on it, and report the details around that. And of course, we interface into Talos Threat Intelligence, and over the last couple of years, we have added a number of AI capabilities to this platform. We have some additional integrations that we have done. We integrate into our SOC platform that we call XDR, our Extended Detection and Response platform. We also integrate into Splunk, as well as our Identity Services Engine, ICE. And we have been working on a number of other integrations with our Catalyst SD-WAN and Meraki SD-WAN platforms. And I'll talk about some of the enhancements that we have because of those integrations a little bit later. Also want to leave you with, we can work with any network device. Secure Access can work with any IPsec capable device, whether it's from Cisco or not. So let's move into some of the high-level use cases that Secure Access supports. If you look to the right, you'll see Secure Internet Access. This is about securing access to the internet for the users. This is what Umbrella has been focused on. What Secure Access adds is the ability to allow users to securely access private resources or private applications. We call that SPA. And then using our head-end functionality in Secure Access, we're able to support different secure remote access use cases that we'll get into a little bit later. And we can have any site connect into Secure Access using standard IPsec connections or native Cisco SD-WAN connections, and interconnect those sites through Secure Access. So what I want to do now is walk through some of these use cases and show you the relevant security capabilities for each of these use cases, and also show you how the traffic is flowing through the platform. So what we have here in the middle is Secure Access. Essentially, it's a stack of security services that we host in points of presence globally. And so we host Secure Access POPs in both AWS and also in Cisco data centers throughout the globe. So in this particular case, this is the secure branch office use case. On the left is where you would have your network device at the branch site. That could be, again, Meraki, Catalyst, could be a Cisco firewall. Basically any device that supports IPsec that can connect into Secure Access. Once that traffic enters Secure Access, it's going to be sent to the cloud-delivered firewall. And depending upon whether that traffic is going to the internet or going to a private application, the path is going to be different. So if we look at the web internet traffic, if you have that, it will be sent to the secure web gateway for content and URL filtering, and then processed by CASB and DLP before it's sent on to the internet. If it's non-web internet traffic, it's going to be inspected by the cloud-delivered firewall and then sent on to the internet. And if we look at the private application traffic path, that's going to be sent to the application through what we call an interconnect. We have something called a private application backhaul that you see here on the right that allows you to have a connection from Secure Access to perhaps another branch location, to a data center, or to a cloud environment where the application is going to reside. Remote users is another use case. This is where you would have an Umbrella roaming module. Again, for those that are familiar with Umbrella, this is the same roaming module that is used in that platform. This would be used with the Cisco Secure Client software that would be installed on that end user's device. And that would basically allow the traffic to go through secure access and have you apply certain web policies on that traffic and prevent data loss prevention. It also would allow you to apply certain security policies based just on the DNS traffic. And then we have remote access VPN. Again, this is for remote users where you would have the Cisco Secure Client software installed. Instead of the umbrella module, you would be using the VPN module that would allow you to bring that traffic into secure access. This is the same VPN client as the Cisco AnyConnect client, if you're familiar with that. So the same capabilities that we have with the AnyConnect client is available here. So meaning that we can support split tunneling, we can send traffic directly to the internet, or we can send traffic, in addition, send other traffic to the VPN tunnel to secure access. Once it gets to secure access, this is similar to what we just saw before. In the secure branch use case, it would hit the cloud delivered firewall. And again, it could go to the internet or to a private application, and you would use the appropriate path based on where it's going to. We have another option to allow users to access private applications in addition to the option using remote access VPN. This option is called client-based zero trust access. So in this particular case, with zero trust access, you would have a ZTA module being enabled in that Cisco Secure Client on that endpoint. And that would enable you to forward that traffic directly to a specific private application through what we call a ZTNA proxy. That would be where you could apply different security inspection before sending it on to that private application. So the difference between the zero-touch access approach and the remote access VPN approach that we just looked at is that with ZTA or ZTNA, we are creating connections per application. So you're creating a connection per app, and that's done behind the scenes or in a transparent way. And what that means is the user doesn't have to be concerned about setting up a VPN tunnel to that application. It's done automatically through these connections. So it's a much better experience using ZTNA versus the traditional remote access VPN approach. There is a one-time enrollment process that the user would have to do by simply just clicking clicking on an enroll button that you see here, entering in their credentials, and once they enter their credentials and becomes authenticated, they will have access to that application, and they'll have a banner that you see at the very bottom that will pop up letting them know that ZTA or Zero Trust Access is active. So from this point on, the user doesn't need to put their credentials in to access an application. They will just have access from this point on. The zero-touch access works at a lower level than the VPN client, and what that means is that the traffic will be intercepted first by the zero-trust access module before the VPN client. The benefit of this is that a user can be running both, right? They could be running Zero Trust Access alongside a Cisco or non-Cisco VPN client. We have another use case. We have what we call a browser-based Zero Trust Access. This is for users such as contractors that need access to private applications. However, you don't have the privilege to install this Cisco secure software on their device. So in this case, they still can access web-based private applications through this browser. So another name that you may come across is clientless. So you may refer to this or hear this be referred to as clientless based Zero Trust Access. We also can perform a number of different posture checks, meaning that before allowing a user to get access to a specific application, we can check on a number of different parameters about their device, as you see listed here. And again, based on whether they are using a VPN client or using zero-touch access, we have a number of different options that could be used. So let me show you a high-level example, a high-level deployment topology of secure access, and show you the connectivity that may exist. If you look at the upper left part of the slide, we are showing a couple branch offices connecting into secure access. In this case, again, you would have a network device that's capable of supporting IPsec connecting into secure access. A typical use case here would be to secure internet access on that branch traffic. And instead of having to backhaul all of that branch traffic to the headquarters before sending it out. So a much more efficient way of securing internet traffic. At the very bottom, what we show here are two data centers, and this is where you may have your internal DNS server, you may have your integrated your identity services engine, and also your private applications that the users would need to access. Again, you would have an IPsec connection back to secure access. And as you can see, the IPsec connection is the same mechanism or the same technology that is used to connect the branch site. There's no difference. We also have, in this example, connectivity to a IDP, identity provider. We support Azure ID, Entra ID as well. And in fact, we can support any IDP that can support the SCIM protocol. So basically, the SCIM protocol is an API-based mechanism that allows you to pull the users and the associated groups into secure access and use that information to help create the policies. And then finally, up in the right-hand corner, we're showing the remote users. These remote users are accessing private applications through different mechanisms, one using the ZTNA approach. We have also VPN tunnels, and also the clientless or browser-based approach. We're not showing the access to the internet, securing the internet, but we simply could allow that as well. And if we wanted to show that, we could add in that umbrella module to do that. Or you could just simply use the VPN tunnel to allow these users to securely access the internet. So let me move into network connections. Again, I want to point out that to support these use cases that we just went through, you will use the Cisco Secure Client on the end device, and that software supports a number of different modules that we just talked about. The ones you see up here are common ones. We have the AnyConnect VPN module, we have the Zero Trust module, and then we also have an umbrella module. There are other modules that are hidden. For example, Thousand Eyes. We have a Thousand Eyes module that supports the digital experience monitoring that I talked about. And then we also have a posture module that's hidden. Here are some additional details about the end user connectivity that we have touched upon. The VPN, as an example, that uses DTLS. That's DTLS over UDP. And one thing to point out is that that is capable of carrying both internet and private traffic. So all ports and protocols are supported. CTA module, that's a more efficient way of connecting, allowing users to connect to private applications than using the traditional VPN approach. The ZTA, the Zero Trust Access, does not have to be concerned about the overhead that you get by using the IPsec protocol. One thing I want to point out is today the ZTA approach only supports private traffic. So keep that in mind. And then we, again, have the web roaming module, which is focused on internet web traffic as well as DNS traffic. So let's move into network tunnel groups. A network tunnel group is a way to connect a branch to secure access and carry that traffic. Think of Umbrella. That it's the same mechanism that Umbrella uses to carry traffic from the branch to the cloud. Network tunnel groups are also used to connect or allow access to private applications. So as shown here, a network tunnel group is consisting of a primary and secondary tunnel. You're going to have a network tunnel group per site. So for each branch, you'll have a network tunnel group, and for each data center, you'll have a network tunnel group connection. When you set up a network tunnel group in secure access, it automatically creates two IPsec hubs. And it's labeled here as DC1 and DC2 within a single region. This provides full redundancy. So these are two separate data centers where data center 1 is supporting the primary tunnels and data center 2 is supporting the secondary tunnels. We also are capable of supporting ECMP. So if you want to scale the amount of traffic bandwidth on this network tunnel group, you can do that. We support up to 10 tunnels, with each tunnel supporting up to 1 gig of capacity. So as I mentioned earlier, we have done some integration with our Catalyst SD-WAN platform. One of the things that we can do because of that integration is automatically create the tunnels within that tunnel group. We also are capable within secure access to recognize the segmentation information that is flowing on that Catalyst SD-WAN tunnel. So both the VPN ID and the security group tag, SGT, that is inside that Catalyst SD-WAN tunnel can be recognized by secure access and be used by secure access to determine what policy should be applied to a specific type of group of users or to traffic that's associated with a specific segment. Resource Connector. This is another option, alternative approach to enable access to private applications, in addition to the IPsec approach that we just talked about. The difference here is Resource Connectors only supports the zero trust access connectivity, whereas the IPsec can support any of the use cases that we talked about. We do, essentially a Resource Connector is a lightweight VM that can be installed in AWS or installed in VMware. Recently we have come out with a Docker version of the Resource Connector, which makes it much more portable. So when you deploy this VM or this Docker container, what will happen is redundant TLS tunnels will be created from the Resource Connector back to secure access. What that means is that you don't have to set up an IPsec tunnel to connect that Resource Connector back to secure access. The TLS tunnels will be created automatically for you. We also give you the ability to support more than one Resource Connector to increase the capacity. And we recommend a minimum of 2 Resource Connectors. When you do that, the traffic will automatically be load balanced amongst those Resource Connectors. So as you can see, we have built in a lot of automation around Resource Connectors. One of the benefits that I want to call out when using Resource Connectors is that you can connect to applications that have overlapping IPs. We support a number of different redundancy configurations when using Resource Connectors. One is shown here, where you have, again, 2 Resource Connectors created. One is connecting back to a secure access point of presence, and another is going to a second one within the same region. Now, if you want additional redundancy, we do support multi-region redundancy with Resource Connectors. So as shown in this example, we have a Resource Connector Group A that has 2 connectors in it. That's being tied back to Region 1, where we have secure access, and then we'll have another connector group called B here that will connect to a second region where secure access would reside. And if you have multiple data centers, we can support this type of topology where one of your data centers aligns with Region 1, and you have another data center aligning with a second region. So I covered a lot. Hopefully I covered a lot of important topics that you weren't familiar with. I want to leave you with a list of other topics I haven't had a chance to get into. There's a wealth of information on our website. So I want to leave you with this list. If you want to follow up on other topics, for example, we have a wealth of APIs that we support in secure access. There's a lot of more information how security group tags work with secure access. And if you want to get into the digital experience monitoring, that would be worthwhile since we continue to add to that type of capability. So with that, essentially I'm out of time, but I want to thank you for spending time in this session, and have a wonderful week at Cisco Live.